Leetcode video, and today we have longest strictly increasing or decreasing subarray. It says you're giving an array of integers nums. Just return the length of the longest subarray, either it's strictly increasing or strictly decreasing. Based on the constraints, again, in these easy questions, they are easy because brute force actually works. You can do a double loop and just calculate the largest, whether it's strictly increasing or decreasing from a single index. However, we have the different solution today, which is O of n, actually, where basically it's a sliding window approach, or it's not a sliding window approach. It's more of a two-pointer approach than a sliding window. We're gonna have 2 pointers, one for the increasing and one for the decreasing. So this is Li, Ld, increasing, decreasing, iterating on the array, right? And I'm just gonna go find. So I'm gonna go for every condition it breaks. I'm gonna move the pointer basically. So for, let's say, for the increasing, it breaks if I found the number less than or equal the number before it, because it's a subarray, right? So then, if that's the case, I'm gonna update the pointer of the increasing. Same goes for decreasing. If I find a number that is greater than or equal, I'm going to update it. So basically, this is for the increasing. I loop of the array, I start from 1. If I find out that there is a number less than or equal the number before it, then I update the max, which is going to be the length of that current part, r minus li. There is no +1 here because I do not want the r with me, basically. Actually, the r actually breaks it, so I don't want it. So the r is not inclusive. And then I update the li to be the r, where it's just a new start for another subarray portion. Yeah. Also, for the other side, for the vice versa, if I found a number strictly greater than the number before it, I want the decreasing. So that's that, and then I take r minus ld, same again, update it. And then after I finish, sometimes you can finish the array without, so if the array is like 1, 2, 3, 4, it's never actually gonna calculate the increasing, because it never goes in these, because they're perfect. Like, not these, but it never goes in the happy scenario of the like increasing, so it never goes here, because this never actually happens, because 1, 2, 3, 4, it's perfect. So what I do is I literally just do this quickly, where I max increasing, I just check the current r after it finishes, which is basically going to be the last index. Yeah, it's going to be the last index, so it's r minus li plus 1, r minus ld plus 1. I do the plus 1 because I actually want to include that r, because the r points to the last index and I need it. So it's inclusive. And then I just return the max between increasing and decreasing, and that's that. Basically, if I run it, it passes, and the time complexity is O of n, space complexity is O of 1. Actually, this is just an edge case, where if it's the length, if the length is 1, it's never going to go in here. It's never going to go in the loop, so it breaks here. So basically, the length of 1 is 1. Just the length is always going to be 1 anyway. So yeah, that's that. Thank you guys for watching. See you in the next one.